Hi dears, I am Jaya Shankar, Assistant Professor, SNIT Adur. Welcome to today's class. Today we are going to study Successive Approximation Method. Now let me explain the method of Successive Approximation. First, you have to assume an approximate value for the variable that will simplify the equation. Then solve for the variable. Use the answer as a second approximate value and solve the equation again. Repeat this process until a constant value of the variable is obtained. So let me explain. First we have to assume an approximate value for the variable. Normally it will be x. After assuming the value, solve for the variable. Then use the answer as a second approximate value and solve the equation again. Repeat the process until a constant value for the variable is obtained. So when constant value you obtain for 2 or 3 iterations, then that constant value is considered as root of the equation. Now, let me explain with an example. Find the solution of f of x, that is x cube plus x minus 1 is equal to 0 by iteration method, correct for 3 decimal places. So, solution is f of x is equal to x cube plus x minus 1. For x, give the value 0, 1. This is the procedure. For x, you have to substitute many values. So here we are substituting 0 first. So x will become 0. So f of 0 is equal to 0 cube plus 0 minus 1, and that is minus 1, and the answer is a negative value. Then f of 1 cube plus 1 minus 1 is equal to 1 you are getting, and that is a positive value. So you have to check the outputs negative, positive. So here for f of 0 it is negative and f of 1 it is positive. So you can write the root lies between 0 and 1. Now we have to find g of x. We are having f of x as x cube plus x minus 1. So x cube plus x minus 1 is equal to 0. Take x out. X into x square plus 1 minus 1 is equal to 0. There x is equal to 1 by 1 plus x square, and that is gx. So you can write gx is equal to 1 by 1 plus x square. Hope this much is clear for you. Now we have to check whether the above found g of x is correct or not. For that, you have to see modulus of g dash of x less than 1 or not. Modulus of g dash of x less than 1 or not. That we have to check. So g dash of x is derivative of g of x. So now we have to find g dash of x. G dash of x is equal to derivative of 1 by 1 plus x square, that is d by dx of 1 by 1 plus x square. As you know how to find the derivative, you will get minus 2x by 1 plus x square, the whole square. Then you have to find the modulus. Modulus means you have to change the sign. You have to take the sign out. So modulus means minus 2x. The answer, the g dash of x we got is minus 2x by 1 plus x square, the whole square. So modulus of that you will get 2x by 1 plus x square, the whole square. You have to check whether it is less than 1 or not. Now substitute various values for x, that is 1, 2, 3, etc. Just try. You can understand that the answers which you get will be always less than 1. That means g of x which we got is correct. So x is equal to, g of x is equal to 1 by 1 plus x square. Now assume x0 is equal to 1. That is what we have written in the steps at the starting. That is, first you have to assume a value to a variable. X0 is equal to 1. With that 1, you are continuing. So first iteration, x1 is equal to g of x0. x1 is equal to g of x0. So you are having the g of x as 1 by 1 plus x square. So here x square, that will be x0 square. x0 is 1. So substitute 1 over here, you will get 0.5. Next is second iteration, x2 is equal to g of x1. This x1. Then 1 by 1 plus x1 square. Substitute the value of x1 as 0.5. You will get 0.8. Then x3, x4, x5. You have to find until some 2-3 iterations outputs will be almost similar. x10 is equal to 0.6853736. x11 is equal to 0.68039. x12 is equal to 0.68355. x13 is 0.68154. So rounding you will get 0.682. x14 we are getting 0.68282. x15 0.6820126. See, 3 decimal points is a question. So here for x13, x14 and x15 you are getting this almost the same answer, 0.682. They are similar. 3 decimal places are the same. So you can conclude root of the equation is 0.682. So this will be the answer. Hope the method is clear for you. Next we'll see how a program can be written for successive approximation method. Now, for the method, we have to write the program. So let me explain. Program to find the root of an equation using successive approximation method in C++. This also you have to learn. Hash include iostream.h, hash include cmath.h. Cmath is used. Header file is included for cos function. The question is for cos calculation. So, cos function execution, you have to include cmath header file. Next is iomanip header file. Iomanip header file is included for set precision function because you have to set the decimal places. For that, iomanip.h, that header file you have to include. So you have included these 3 header files, that is hash include iostream.h, hash include cmath.h, hash include iomanip.h. Now using namespace std, see the next step, double f of double x. We open the curly bracket, return double cos x minus 3x plus 5. This is the equation you are having. This is what you are solving using the program. So this return the equation whose root is to be determined, where we have used the equation cos of x minus 3x plus 5 is equal to 0. So return double cos of x minus 3x plus 5. Now after that you have to find the g value, g of. That is double g of double x. In this function we have return x. For cos x minus 3x plus 5 is equal to 0. Value of x will be cos x plus 5 by 3. So you are taking x out and you will get cos x plus 5 by 3. That will be x. X will be equal to cos x plus 5 by 3. That you have to return. Then int main section, you are declaring x0 and xn as double and you are initializing xn as 1. Iteration 0, that is iter is the iteration, that is also integer. Then cout, enter the initial approximation. See, in the example we have considered x0 as 1. We have assumed x0 as 1. So that is what we are doing here. C in x0. Then cout iteration x0 xn, that will be printed. See the calculation, while f of x0 into f of n xn greater than 0, xn is equal to x0, x0 plus plus. You are assuming it. Previous value you are assuming to the next iteration and you are incrementing the iterations one by one. Now again next condition, while FABS xn minus x0 greater than 0.000001, that is error, accepted error, where FABS returns absolute value of the argument. x0 is equal to xn, xn is equal to g of x0, you are assuming. See, x of 1 is equal to g of x0. Then iteration plus 1, you are doing it up to 6 decimal places, set precision 6. Then print cout, the root of the equation cos x minus 3x plus 5 is equal to 0 is xn. So this is the answer. Return 0 and close the curly bracket. Hope you understood the program. As assignment question, I have given four questions over here. So you have to solve and submit it. First question is, find the root of x square minus 3x plus 1 correct to 3 decimal places. Second question, find the root of equation x minus 0.5 cos x is equal to 0 correct to 5 decimal places. Question number 3, find the root of equation 3x minus cos x minus 1 is equal to 0 correct to 3 decimal places. And fourth question is, find the root of x cube minus x square, find the root of x cube plus x square minus 100 is equal to 0 that lies between 4 and 5 by using iteration method. Here it is given, the root lies between 4 and 5. So for solving this cos, sine and all, you have to do radian method using your calculator. Then only the answer will be accurate. Thank you, dear students. We have completed how a problem can be solved using successive approximation method. We'll see next topic in next class.